All right, we are back here again. We're going to finish up our conversation about how we solve triangles when we have incomplete information using our trigonometric functions. So, from the previous videos, we have looked at four different situations where we have three pieces of information about a triangle, and we want to figure out the other three pieces of information that's missing. So when I'm talking about pieces of information, I'm talking about lengths of sides and measurements of angles. And the first two situations we discussed were the case where we knew two of the angles and any one of the sides of the triangles, and this would cover both angle angle side and angle side angle. Doesn't matter, same techniques done both sides. And we learned how to use the law of sines to solve triangles of that situation. Then we learned how to do the cases where we had two sides and an angle that was not between those two sides, the side-side angle situations. These were the ones that we also called the ambiguous cases, because when we're initially given the information, we don't know without further investigation whether a triangle exists or not, and if a triangle exists, if it's one triangle, a unique triangle, or if there's two possible triangles. And again, we learned how to use the law of sines to solve these types of triangles. The two remaining types of triangles that we can solve using trigonometry are side, side, sides, where all we know are the sizes or the lengths of the sides of the triangle, and side, angle, side, where we know the lengths of two sides of the triangle and the angle in between them. And for these two situations, we're now going to have to learn the law of cosines in order to figure these out. So both of them use the same formulas to solve them, and similar techniques once we use the formula. Now, the reason that we can't use the law of sines for side, 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 or side, angle, side, is because these two situations provide us with either the length of a side or the measure of its opposite angle. So, if we were using the law of sines, we don't have both the top value and the bottom value of any of the ratios that then allows us to figure out what the other ratio should be equal to. We can't solve the proportion if all we have is one A value, one B value, and one C value, whether it's the length of a side A or the measure of an angle A. We need to have, at least for one pair of those, both the side and the angle measure in order to use the law of sines. When we don't have that, then we have to use the law of cosines. So what is the law of cosines? Here it is. Okay, now this may look like it is a lot of formulas. And on the page right now, there are 6 formulas. But at their core, it's one formula that we just modify in different ways to get different formulas. So when we are talking about it in general, okay, what the law of cosines is talking about is that for any one of our three sides of the triangle, the square of that side is going to be equal to the sum of the squares of the other two sides minus this term 2bc cosine of A, or 2ac cosine of B, or 2ab cosine C. It's going to be the sum of the two other sides minus 2 times the product of those sides times the cosine of the angle opposite to the side we're figuring out. So here in our standard form, all three of these formulas, the top three formulas, are essentially the same formula. It's just a question of where do sides A, B, and C and the angle fall in them. Below, I wrote out what we call the alternative form. And these are the forms if we just solved for the cosine of the angle. And you'll see that in each of the cases, the cosine of either A, B, or C is going to be equal to a fraction that involves all three sides of the triangle. So where we normally have in triangle trig, we would define the cosine through a right triangle as adjacent over hypotenuse. Here, for any triangle, we can define it by the three sides of the triangle. The nice thing about the alternate form is that once we calculate here this b squared plus c squared minus a squared over 2bc term, then we can take the inverse cosine of it to figure out what our angle is. And that works just the same whether we're talking about cosine of B or cosine of C. So if you're looking to memorize any formulas here, what you want to do is memorize these top formulas and then realize that you can swap out BC for A just by using this one standard form. Okay, learn the top alternative form and just understand that for any one of your three angles, it's going to be the sum of the squares of the other two sides minus the square of the opposite side over this 2bc term. Okay, and it's the same for all three of them. So how do we go about solving triangles using the law of cosines? I am glad you asked because I have some example problems set up. So let's say we're given the three sides of a triangle. In this case, we're told that one side is 14, the other side 17, and then we have a third side, which is 25. We're asked to solve this triangle. So solving this triangle means that we have to figure out what are the measures of the three angles of A, B, and C. What I'm going to do is I am going to go and use the law of sines to figure out what my angle A is. Okay, I could choose any of the three angles. Doesn't matter which one I choose. Process is going to be the same. I'm arbitrarily just going to go with figuring out what A is. So that means I'm going to use the alternate form of the law of cosines. Again, that was cosine of A, because that's what I'm trying to figure out, is going to be equal to the sum of the squares of the two adjacent sides minus the square of the opposite side. So in this case, b squared plus c squared minus a squared, and then all over 2 times the product of the adjacent sides to this angle A. Which is this all going to work out to be, since b is 17, 17 squared plus 25 squared minus 14 squared all over 2 times 17 times 25. If we plug this into a calculator, we're going to have that this is going to be approximately equal to 0.8447. So that's what my cosine of A value is going to be. And then to find A, I'm just going to take the arc cosine or the inverse cosine of that value and plugging that into calculator will get me a value of approximately 32.4 degrees. There we go. We are one angle in at this point. I'm going to go over to where I'm keeping track of all my values, plug that in. Now I'm going to do it again for a second angle. And here's where I have a choice of how I want to do this. I could do the law of cosines for my angle B and do this entire process. And generally on side, I find using the law of cosines to be the easier way to figure out my B angle. Or if I feel more comfortable doing it, I can switch over to law of sines at this point, because now I have a situation where I have two sides and an angle. And the nice thing about this is that this is not ambiguous anymore, because if I'm given the three sides, this is not ambiguous triangle. So I can now just start calculating using the law of sines what B would be in this case. But I'm going to go ahead, I'm going to use the law of cosines one more time just so we're getting the practice in. And I'm going to go ahead and I'm going to figure out now what is the cosine of B. And this, by the law of sines, is going to be a squared plus c squared minus b squared all over 2ac, which is going to be the same as 14 squared plus 25 squared minus 17 squared. That's all going to be over 2 times 14 times 25, which if I plug that into a calculator is going to give me not approximately, actually exactly 0.76. And then taking the inverse cosine of 0.76, that will get me an angle that is approximately 40.5 degrees, which is what our value for B is. Okay, popping that up here. And then my last step, I'm going to subtract A and B from 180 to figure out C. I don't want to use the law of cosines to figure out C, because rounding might cause it to become a little bit off from what its actual value is. And the main thing that we have to always remember is that A plus B plus C has to equal 180. If you give me answers of A, B, and C that don't sum up to 180, even if you used the law of cosines to figure out each of these individually, that is not a triangle, right? A triangle has to add up to 180 degrees exactly. So that's why I say use the law of cosines to figure out the first angle, use law of cosines or law of sines to figure out your second angle, but use the triangle angle sum theorem to figure out whatever your third angle is. And if we plug this into a calculator, it's going to pop out that it's 107.1 degrees. All three of these add up to 180, and that's your solution to this triangle. All right? So that's how we use side to solve for a triangle. We use the law of cosines to figure out whatever our first angle is. We can then go ahead and use the law of cosines again to figure out our second angle. And then whatever's left over in 180 is going to be what our third angle is. So that's side. Now, what if we have two sides and the angle in between them? Well, in this case, we are going to want to use the law of cosines to solve for that first side first. So we're going to use the standard form of the law of cosines here. Here I am told that side A equals 13 in length, side B equals 24 in length, and I have the angle in between them, which would be angle C, is 45 degrees. So setting up the law of cosines, that means that C squared is going to be equal to A squared plus B squared minus 2 times AB times the cosine of C. Plugging in the values that we have, that means 13 squared plus 24 squared minus 2 times 13 times 24 times the cosine of 45. And plugging that into a calculator gets me a value of approximately, for C squared, 303.7654. See, while normally I like on my lengths to go to the hundredth position, at this point I want, when I'm approximating, to go all the way out to the 10,000ths because I have to square root this afterwards. And if I go out those 2 extra digits, it's going to give me enough extra space on my square root that I'm going to get a pretty good approximation. All right. So if I square root both sides, that is going to tell me that C is going to be 17.43. And that goes into my table. That's my first value. Okay. Now, for side angle side, when I figure out my first angle value, I can use the law of cosines here, and I can set it up just like I did for the side. But generally, this C, this third side, is going to be a messier number. It's going to have a couple of decimal places. So in this case, I tend to like to use at this point to switch over to the law of sines to figure out what my angle A is going to be. So to find out A, I'm going to do the reciprocal version of the law of sines. So in this case, sine of A over A is going to be the sine of C over C, which means that if I solve for A, or solve for the angle A, sine of A is going to be equal to 13, which is my value for A, times the sine of 45 degrees, all over 17.43. Plugging that into a calculator will get me approximately 0.5274. Now I'm going to want to take the inverse sine of this value to get me an A, and the measure of my angle A is going to be approximately 31.8 degrees. Okay, so I'm going to take that, plug that into my final answers, and then just like with the side situation, here I'm going to take my angle C, my angle A, and B is just going to be whatever's left over in 120. So B is going to be 180 minus 45 minus 31.8, and that's going to give me a value of approximately 103.2 degrees. And there we go. Done right there. Easy peasy. And that's my solved triangle at this point. So the one thing to keep in mind is that whether it's side or side angle side, when I can use the law of cosines, there's nothing ambiguous about these triangles. There's only one way to solve each of these triangles. Think back to your days of geometry and remember how side and side angle side were ways of proving congruent triangles. So that means that there is exactly one triangle in the entire universe that can fit all of this different information, and the law of cosines allows you to solve that. So give the problems in your review sheet a try, and come to me if you have any questions.